So now we are going for a derivation that is also important if I consider the previous year questions. So that this is a combination of two cells. Two cells, that means we have two cells. So you can just draw two cells here. So this is one cell and there will be another cell. Okay, these are the two cells. Let's say E1 is the EMF of first and E2 is the EMF of two, and then we have R1 and we have R2. So now we have 2 points. Let's say it is A and B. These are 2 points. Let's say one more point that is called C also in between the cells. I am just taking a cell which is having an internal resistance R equivalent and EMF is equivalent, and I'm saying whatever work the above combination will do, the same work can be done by E equivalent on R equivalent. So E equivalent is the net EMF, equivalent EMF of E1 and E2, and R equivalent is the net resistance of of two cells in series. Okay, so now I want to find out these two terms. For this, we have to use a mathematical equation. So let's write down how we will start. First, we will write the potential difference between A and C. Then we write the potential between C and B. And finally, we will find out the potential of A and B. So let's write down the potential difference between A and B. But before that, you need to write down VA minus VC. Okay. And this will be equal to. So use the equation. V is equals to E minus IR. Why I am taking minus? Because current is coming out from the positive terminal. That is minus sign will be there. If it is going into the positive terminal, then I have to write plus. So now this is V and this portion is V, and you can write E plus E minus IR. And now actually E between A and C is only one cell that is having EMF E1 and having resistance R1. So I'll put E1 and R1. So this is the equation number 1. And now I want to use another one that is called VC minus VB. So while writing VC minus VB, you can write E minus IR again. Just check current is drawn from the positive terminal. So and just write E2 and R2 because we are writing for E2 and R2. And this is our equation 2. So this is easy for everyone to write now. And now if I just add both the equations, so this terminal, if I add, so you see this negative terminal, this minus C and minus C will cancel out. So you can write finally VA minus VB equal to, add these two, E1 plus E2, that is okay, minus IR1 minus IR2. So this is how you can write. Now I want to say now I can just rearrange this thing. This is VA minus VB equal to E1 plus E2 and minus I into R1 plus R2. Okay, so this is the equation number 3. Is that okay? Now this is the equation number 3 for us, and you can write the same equation for this combination. So this equation is for the above combination, and you can write it as for this combination as well. If you want to write down, so you can write VA minus VB, and how many cells are connected between A and B in this diagram? That is only one, and it has EMF E equivalent. As current is drawn from the cell, so obviously minus sign, and the current is I. Obviously we are saying this, it is doing same thing. same work. So that is why it has to give same current. So same current it is giving, and internal resistances are equivalent. This is the equation number 4. So from this equation you can simply say, from this equation you can say, so from equation 3, from equation 3 and 4, from equation 3 and 4, what you can compare between these? So you see, left hand side of both the equations are same, so you can say right hand side are also same. In that case you can write E equivalent is E1 plus E2. So this is the first thing we can have. And the second one is R equivalent is equals to R1 plus R2. So this is how you can get the two things, total equivalent and total equivalent resistance and total equivalent EMF. So now if we connect cells in series, so you can add all the EMFs, and similarly if you have and similarly you can add all the resistance to get R equivalent. So you discuss few special cases in that also. So for example you have n cells, n different cells, okay, n different cells, n different, so you have n different cells. So you will write E equivalent is equals to E1 plus E2 plus E3. I will not write all the values, I will mark it up to n. Similarly, you have R equivalent R1 plus R2 plus R3 and keep on up to n terms. Now, if we have n identical cells, that is very important, identical cells. So if you have n identical cells, so now what you will do? Now what you will do, E equivalent will be equal to, equivalent means like identical means which have same EMF and same internal resistance. So it will be E plus E plus E, and it will go to n terms. Okay, n terms. So if it goes to n terms, obviously I can write NE. So please remember this thing, that this will be like this. Is that okay? Hopefully this will make some sense. Now similarly R equivalent will be R plus, it will not be there, no any. Now R plus R plus R and up to n terms, up to n terms, and similarly R equivalent will be NR. So this will be the two important or special cases which you need to special case. So you need to remember this. Okay. And one more important point I just want to explain here as well. If you have, assume that you have a cell, you have a number of cells, and these number of cells are connected like this, that is perfectly okay, and all are identical, okay. Let me just change the scenario, and it will be like different, and it is R1, R2, R3, R4 and R5. Now how can I write E equivalent? So E equivalent will be, you can write easily, okay. So E1, E2, E3, then E4, then E5, then R equivalent is R1 plus R2 plus R3, R4 and R5. So this is how you can write easily. And then but I just want to change it, and what I will use here is, I will take one thing here is, I'm just switching the cells. Okay, so I have switched only one cell right now. This is E1, E2, E3, E4 and E5, and this is R1, R2, R3, R4, R5. So now how can you write down E equivalent? As the battery is opposite, so I will mark just opposite sign. Okay, which battery is opposite? E4 as compared to other, or reference you can take other. So now everything will be written like this. Okay, and then R equivalent will be R1 plus R2 plus R3. What do you think? What do you think? Which sign will be there? Plus or minus? Actually, resistance doesn't have any direction, so please don't mark that minus, because minus resistance is not possible. Okay, so these two are very, very important. Okay, so I'm just taking one example, one more last example in with this, which is very, very quite like very, very important. Why it is important? Because many a time it is okay, it is important. So I want to discuss one example which has which has I want to discuss an example which has identical cell. Okay, but one cell is connected in opposite direction, but they will not say they will not give you direct diagram. In examination they will give you in writing, will give you that three cells are connected, connected such that two are connected in same order, third one is connected in opposite direction. So the diagram will be like this. But if you read the question and they will not give you the question, they will not give you the diagram. So what you will do, you will say okay, three cells, 3 is the EMF and one cell is opposite, so it will be minus, so it will be 2E. But please remember, this is wrong, because when you connect three, so see, do in that way only. So three cells are connected, two are connected like this, one will be opposite. So how much it will be? Only E. So this you need to remember carefully. And R equivalent is like that only, because R cannot be negative. So it will be 3R. So E equivalent is E and R equivalent is 3R. You can take an example of five cells out of which two are connected, in opposite manner, so you can just give the answer in comment that it is what is E equivalent, and take these are identical cells. So E, in terms of E and R, please give the answer for E equivalent and R equivalent. Let's do the same thing for the parallel combination. So we have two cells in parallel. So let's draw a diagram of two cells which are in parallel. So when they are in parallel, so assume that they are in parallel like this, and we have two terminals A and B. This is E1 which is having resistance R1. This is E2 which is having resistance R2. Let's say I current is going from two cells, that is a total current. So using Kirchhoff's law, I can just mark the current in these two cells as well. The same current has to enter in the cells, because the whatever the current leaving from the cell, that current has to enter into the cells to have continuity. So now we have I current, so this will be I1, this will be I2. So we assumed that we have two currents, I1 and I2, and this relation is confirmed using Kirchhoff's first rule or first law, that I is equal to I2. This is our Brahmastra, and we will use it in this derivation. So as you have two cells E1 and E2, but they are in parallel. So one more point you can write, in parallel, what is there? Potential is same. So potential difference across two cells is same. Okay, now we will write, so V is the potential across E1 and V is the potential difference across E2, but there are the two paths, so we will consider two paths and we'll write the potential difference of A minus potential difference So we will write potential difference between the point A and point B via, okay, so we'll go via E1, and that can be written as V, and it will be E1 minus IR1, because one cell current is I, actually current is also I1 here. So E1 minus I1 R1, this is our equation number 1. Similarly, you can write potential difference of A Similarly, you can write potential difference between 2 points A and B, which is VA minus VB via E2. This time again the potential is same, because in parallel voltage is same, but now the cell is E2, so we'll write the equation in terms of E2. Current is I2 and resistance is R2 as well. We have these two equations. Now what we are going to do, we will find out this. You can remember, so that you can understand, or you can remember this derivation for long. So now find out, this is the step, find out I1 and I2 to I1 and I2, and put the value, put these values and put these values in equation 1. Okay, why we are doing this is the question now. So as we have done in the last case, if I want to connect only one cell instead of these two, but same current will release, so I will take an example, and in that example you can take the 2 point A and B. Between these 2 points, will consider only one cell, will connect to only one cell which has an which has a EMF equal to E equivalent, and which has a resistance, internal resistance, equal to R equivalent. But the same current it will give, same current, whatever the current the above cells are giving, the combination of parallel combination of E1 to is E1 and E2, they are giving the same thing. E equivalent is also given. So we can consider the equation of for this diagram. So write down the equation again. So VA minus VB, which is equal to V, and that will be equal to, because same potential it will give also, and it will be E equivalent minus IR equivalent. Now I want to compare this relation and a relation which has current I, some EMF, the maybe in terms of E1 and E2, and the internal resistance in terms of R1 and R2, or maybe something, some mixed value. So in that case, you don't want the value of I1 and I2. Now you have to put the value in equation 1, so that you can get I1. So we have two equations now, and find out the I1 from here. So this is the equation number 1 which we got, and 2 also. So find out I1. So this term I'm taking to this side, so it becomes plus, and this term we are taking to this side, so it will become minus. So I will write I1 R1 equal to E1 minus V, and finally I got I1 is E1 minus V by R1. So this is our first equation, equation number 3. And then we have another thing. So now we want to find out I2. So similarly, you can just do it, and I'm just writing directly. So it is E2 minus V divided by R2 is the equation number 4. Now I will use 3 and 4 in the equation, which is I equal to I1 plus I2. In that case, we will get a final equation in terms of E1 and E2 and V. Okay, So I also, not I1, I2. I want equation in terms of I, E1, E2 and R, as well as we want V. And V is the potential difference between 2 points. So put the value. So I will be equal to E1 minus V over R1 plus E2 minus V over R2. This is the simple equation I can just write, and then you just do it once. E1 over R1, separate or distribute R1, and then E2 by R2 minus V by R1. Actually, I want E1 and E2 together. Okay, that is why I'm doing this. So if you, so to get E1 and E2 together, we have to distribute R1 and R2. Now you can see I can write easily this term. And also we can write V over R1 minus V over R2. Actually, this is R2. Now I equal to E1. I just do one thing. I just take an LCM, this LCM now. So it will be R1 and R2. And this comes to be E1 R2 plus E2 R1. This is very important formula. Please remember this. Okay, we'll discuss just after completing this. So I can take common as minus V. So it will be R1 and R2. Then finally, I can write the same equation E1 R2 plus E2 R1. When you do this derivation 1 or 2 times, you could remember it easily. There is no need to mug up the things. You just go with 1 or 2 times derivation. You will remember the derivation as well and the terms as well. So I will write I1 R2 and it will put R2 plus R1 or maybe R1 plus R2. Doesn't matter. We have I equal to E1 R2 plus E2 R1 divided by R1 R2 and minus with this. V I1 R1 V into R1 plus R2 over R1 plus R1 into R2. I want the relation in terms of V equal to E minus IR. I have to rearrange the things. So let's bring this term to the left and this term to the right. Okay, so I can write it as R1 plus R2 divided by R1 R2 equal to E1 R2 plus E2 R1 divided by R1 R2 and minus I. And then V equal to, just do the cross multiplication of the things, plus E2 R1 divided by R1 R2 into, when you do the reverse, the cross multiplication, when you do the cross multiplication, you will multiply the term by R1 R2 and you can divide it by R1 plus R2. Similarly, you will do for I as well. So you have R1 plus R2. Now this term, so this term and this term will cancel each other. So we have E1 R2 plus E2 R1 divided by R1 plus R2 minus I into R1 R2 divided by R1 plus R2. So this is our equation. And if you do one more thing, if you can write the equation for this E equivalent, R equivalent, and the points are same, A and B. So if I want to use only one cell instead of the parallel combination of 2, I can write the equation V will be equal to E equivalent minus IR equivalent. Now you have to compare these two equations, and on comparing you can see what I can write here. So you can see E equivalent is E1 R2 plus E2 R1 divided by R1 plus R2, and R equivalent is R1 R2 divided by R1 plus R2. Could you remember something from here? Actually, it is the parallel combination of the resistors. So I can write it as 1 upon R equivalent is 1 upon R1 plus 1 upon R2. This you can write. Okay. So from here, I can write one more thing, which is special case. So special case, what I can write, that is E equivalent upon R equivalent. If I divide these two things, what I will get this R1 divided by R1 plus R2 and divided by R1 R2 divided by R1 plus R2. So these two terms can cancel each other. So let's cancel it out, this one and this one. And the final term E equivalent upon R equivalent will be E1 R2 plus E2 R1 divided by R1 R2. Or if I simplify it, it will be R1 R2 R2 plus E2 R1 divided by R1 R2. R1 will cancel R1 and this one will cancel this one. So finally you get this equation. You have this E equivalent, that is E1 over R1 plus E2 over R2. Just let me write one more thing, that is R equivalent. So this is also an important relation which they can give you in MCQs also. They can ask which expression is correct in case of parallel combination of two cells, two different cells. Please remember these things. What you can remember, you can do one thing, that is you can do one more thing, that is this you need to remember, as well as you can remember one more point. You can remember this thing. Okay, just let me do one more. So yes, so you can remember this formula and this formula, which is very, very important. Okay, and the final thing is this. So let's do one more thing in this. If we have a special case again, if we have, for example, n different cells, okay, and different cells in parallel. If we have n different cells in parallel, so you can write directly E equivalent upon R equivalent. They will ask this only because this is very, very easy to write. Otherwise, if you write the formula, that will be difficult. This will be R2, this will be R3, and keep on up to n term. Okay. Now I just want to do one more thing in it, that is n cells in parallel, which are, so n cells, n identical cell, let's say identical cells in parallel. So when they are identical, what will happen to E equivalent? Actually, E equivalent is, you can just repeat after me so that you can remember it. So it will be E1 R2 plus E2 R1. Ulta karna hai. So it will be E1 R2 plus E2 R1 divided by R1 plus R2. Please remember, it is R1 plus R2. Okay, there is a plus sign. That is very, very important. And R equivalent will be simple, R1 R2 divided by R1 plus R2. You can also write 1 upon R equivalent is 1 upon R1 plus 1 upon R2. So now if all are equal, that means E1 equal to E2 equal to E, R1 equal to R2 equal to R, then E equivalent will be E into R plus E into R divided by R plus R. So you will get 2ER divided by 2R. So you'll get final is E. So potential is same. E equivalent is E. Potential is same. And R equivalent is R into R over R plus R. Again, it is R square upon 2R. So it comes to be R by 2. So it will be similar to parallel combination of registers. Parallel combination of registers. So please remember these things, these final expression in series, we have, in case of series, in series we have E equivalent is E1 plus E2 plus E3. Okay, and R equivalent is R1 plus R2 plus R3. But in parallel we have E equivalent is E1 R2 plus E2 R1 divided by R1 plus R2, and R equivalent is R1 plus R no and R equivalent is R1 into R2 divided by R1 plus R2. In case of identical things, E equivalent in series will be equal to NE if N cells are there. It will be NE, and R equivalent will be NR if N identical cells, identical cells. And in parallel, E equivalent is equal to E if they are identical, and R equivalent will be R by N. Okay, this will be R by N. Please remember all the four things so that you can do questions easily.